Hello, this is a continuation of Lesson 5-3, Solving Compound Inequalities. That started on page 227, or 277, can't talk. I'm currently on page 280 where I'm looking at example 4. Example 4, we're going to be doing overlapping intervals, and we're going to graph it the same as an OR compound inequality. It's the graphing that's going to be a little different. So let's solve our inequality. I'm going to start with subtracting 12 minus 12 on both sides. I now have 4k is less than 2 minus 12 is negative 10. I'm going to divide by 4 to get k by itself. Divide by 4. My sign stays the same. And negative 10 divided by 4 is negative 2.5. Now I'm going to do the other side. I have a 4 that I need to subtract, minus 4 from both sides. I now have negative 2k is greater than 4 minus 4 is 0. I can't stop there just because it's 0. I need to get k by itself. So I'm going to divide by negative 2, negative 2. I've got a k. I divided by a negative, so my sign flips, and this is still 0. This is where everything changes. Let's graph this one first. I have k is less than negative 2.5. So here's negative 1. Negative 2.5 is about right here. I'm going to have a line that's going this direction. Let's graph the other one. K is less than 0. Well, 0 starts here. And when I draw this line from 0 to less than, watch what happens. It lays right on top of the line for k is less than negative 2.5. So because this inequality overlapped and covered up this inequality, we are not going to use this inequality as an answer. We're not going to graph this negative 2.5. It's invisible. It got covered up. It's like if I cover up, you can't see it. This graph covered up that graph. When we write our answer, we're just going to write this as the answer. So we're not going to have OR in this situation. It's just going to be this solution. So you'll have to go write it in set builder notation in order to prove that it is just one solution. Go ahead and go on to the check. If you haven't done this lesson yet, pause the video and do the check. Now that you're done with the check, we're going to solve and see how you did. So I'm going to separate these a little bit. Over here, I'm going to subtract my 7. So minus 7 minus 7. I have 4m is greater than or equal to 19 minus 7 is 12. I'm going to divide by 4. I'm going to divide by 4. M is greater than or equal to 12 divided by 4 is 3. I can't choose my answer yet. I got to do this side. Subtract 5. Subtract 5. Negative m, don't drop your negative, is less than or equal to negative 5. Can't have a solution with a negative variable. So I'm going to divide or multiply by negative 1 in order to flip the signs. Negative m times negative 1 is positive m. Flip my signs because I divided by a negative. Negative 5 times negative 1 is positive 5. Now, I still don't know. I would choose this one right now if I'm like, oh, look, I got 2 answers and I was in a rush. You should graph it first. I have m is greater than or equal to 3. So I'm going to put a closed circle on 3. M is greater than. So I'm going to go this direction. Now if I do m is greater than or equal to 5, there's 5. So I'm not going to graph 5. And this is not going to be part of my answer. This is going to be my answer, which gives me A. Next, I'm going to go to example 5. this is a pretty simple, we're going to write the inequality for the intersection. So they gave us the graph, now we have to write the inequality. So here I have a -2. Here I have a 4. The line in between represents x. X, this line, is greater than this -2, so I'm going to use my less than sign because -2 is less than x. It's open, so I don't need is equal to. 4 is a closed circle, so I need the is equal to, and x is less than this 4. And there we go. We have written the inequality for this graph. We're going to move on to the check. Again, if you have not done this lesson yet, pause the video and try the check on your own. So here I have a 7, an x, and a 9. Open circle, closed circle. 7 is less than x. X is less than or equal to 9. And that gives me an answer of D. I know it couldn't be or because I don't have two separate ones. On to example 6. We're going to do the same thing except for we're doing this for a union. So for our or, when we see them separated like that, we're going to go ahead and write the word or. I'm going to start with my x on each side. My number here is 8. My number here is 12. This one has an is equal to, so I'm going to put my line. X is less than 8. Don't have an is equal to here, so I don't need a line. X is getting bigger. It is greater than 12. And that's how we would write this inequality. If you haven't done this yet, pause the video and try the check. Here I have or. I have an x and a 1, an x and a -1. This x is less than or equal to because it's closed. This x is greater than or equal to because it's open. This has an and, so that's not it. This is set up like an and, that's not it. This one says or, but it doesn't have the is equal to, so that's not it. Our answer is A. Moving along, you do have some practice questions that I would like you to do before you do the assignment on McGraw-Hill. So if you have not done these practice questions, go ahead and pause the video and do the practice questions. If you get stuck, you can play the video and walk yourself through it with me on the video. Now, the book does tell you to graph, but it didn't give you a number line, but you're able to write your own number line. I'm just going to do simple number lines. They're not going to have all of the information a normal number line usually would. So here I'm going to go ahead and solve. I'm going to go plus 6, f is less than, 5 plus 6 is 11. Plus 4, f is, I almost did the wrong, greater than or equal to 6. Now when we do ands, we need to squish them back together. So I actually want to go smallest number first. The pointy side still facing the 6. F is going to go in the middle, and then I can finish it with the less than 11. To graph this, your number line, we would have a 6, 7, 8, 9, 10, 11. Closed circle on 6 and an open circle on 11. And they would be connected in between. For number 3, add 1, add 1. Y is greater than or equal to 8, or minus 3, y is less than -3. 4. This is an or, so I'm going to have 2 lines on my number line. I'm going to go -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 there. -4 there. I'm just going to do a couple more after each one. I know that y is greater than or equal to 8. So on 8, I'm going to have a closed circle, and it's going to go greater than, so it's going to go that direction. Y is less than -4, so I'm going to have an open circle on -4, and I'm going to go this direction. When you write these, remember you have to have the word or, and you need to put the smaller one first. So we would write y is less than -4, or y is greater than or equal to 8. Moving right along, we're going to number 9. I'm going to subtract 5, negative y is greater than or equal to 4. I can't have a negative variable, so I'm going to divide by -1, divide by -1, y, flip my sign because I divided by a negative. 4 divided by -1 is -4. Or, do another one, -4, 3y is less than -9, divide by 3, y is less than -3. I don't know which one's my answer. Let's graph it. 0, -1, -2, -3, -4, -5. Let's go. 1, 2, -3. So if I graph y is less than or equal to -4, I start here and I go this direction. But if I do y is less than -3, I start here and go this direction. So my -3 would lay on top of my -4. So this is the graph that I would show. This would not be my solution. This would be my solution. On to my word problem, number 17. Gotta practice the word problems. In Randy's town, all standalone signs must be exactly 8 feet high. When mounted atop a pole, the combined height of the sign and pole must be less than 20 feet or greater than 35 feet, so they do not interfere with the power and phone lines. Write a compound inequality to represent the possible above-ground height of the poles. So they said the signs must be 8 feet high. They're talking about just this part right here. Those must be 8 feet high. So I'm going to go ahead and write 8. I don't know what I'm doing with it yet. When mounted atop a pole, so when the sign is on top of the pole, do we know how tall the pole is? I do not. So I'm going to go ahead and add x to 8. The height of the sign of the pole must be less than 20. So this must be less than 20. So that means 20 is greater than that. Or the combined height must be greater than 35. So this must be greater than 35. So that's how I found my inequality. Now let's solve. I taught the little trick, I think, to most classes yesterday. We're going to go to -8 from all sides. I'm left with only x. 20 minus 8 is 12. 35 minus 8 is 27. And this is my inequality. To graph this inequality, you would have an open circle on a 12, and eventually you would have an open circle on a 27 on a number line. Moving along to number 19 and 21. I've got my x in the middle. Over here I have my -3. Over here I have my +3. This one is closed. This 3 is greater than the x, but x is less than this 3, so we're going to use a less than sign. This negative 3 is less than this x. There we go. 21, I see a space. We're going to do or. We've got a line here and a line here, the number negative 2 here, and 1 here. This line is less than negative 2, so x is less than negative 2. This line is greater than or equal to 1. And there we go. I will do exit tickets on Friday when I am back in class. Make sure that you do your McGraw-Hill assignment for this lesson.